Where was I? I think I was going through the analysis tasks. Carving extraction, just as I said, you need to plan it because they run for hours. Usually ours on the 4 terabyte thing ran for 12 hours or more. And if you forgot something, well, it's 12 hours again because you're running them on the original files and it takes the same time every time. You can speed them up if you're doing it with TCP dump because it's faster, but it still depends on what you're going to do. So if you're using display filters that do not work as capture filters, you cannot use it. So TCP dump can only be used if you're running something that can be expressed as a capture filter.
When you quoted those numbers, like 4 terabytes and all that, were they compressed or?
No, the 4 terabytes are totally uncompressed. 7,600 files of 512 megabytes each, uncompressed, not sliced, nothing, full size. It was I captured over the duration of, I think, 4 or 5 days. And it was an interlink of a company that also had their own servers running, so we excluded their web applications using capture filters. Otherwise, we would have ended like in a 2-digit terabyte number, probably. Yeah, so we're supposed to only capture the traffic coming from inside the company, but not the ones coming from the outside to the company. But the capture filters we were given, or the IPs I was given to reduce the amount of data, weren't complete, apparently. There were a lot of communications in there that still did a lot of damage to the capture files, so to speak. And the first thing that we basically did was remove all of those that we could find that are clogging up the capture files and didn't help us in any way. So I filtered on the biggest communications that we didn't need and removed them. So we had a smaller set, then we could work faster. We got down the 4 terabytes to 1.3 terabytes doing this. And then we needed to work on only 1.3 terabytes, which is much better, but still taking a long time. Okay, so if you're filtering, you can do it manually in Wireshark or other tools, and that only works for, well, small files. So usually what you're doing is running a T-Shark batch job. Christian already did that in his talk, so what I would do is something like being in this directory, for example, write a batch job. Is that big enough? Should I increase the font size? Who wants this font size to be bigger? Okay. Let's do that. I think let's go for 28 or let's try 28. I think that should work. That good? Or even more? Who wants more? Nobody. Okay, then it's good. Let's say I'm going for T-Shark minus R, reading a file, minus uppercase Y, give me DNS, and write it back to something like this. Yeah, reading a file, getting the packets, writing it back. There's a couple of problems with this line right here, which are, first of all, I have to do this for all the files by hand, which is not a good idea. And second of all, which is much more important, what is going to happen if I run this? I lose my original. Yeah, that is a very bad idea. Actually, what I did after having captured 4 terabytes of data, do you know what the first thing was that I did? Set the read-only flag on those files. That was the first thing I did. So that whenever I tried something that would overwrite them, I would get a warning, and I'm like, oh, I'm doing something stupid. Yeah, because 4 terabytes, I would have preferred to do a copy and work on that, but 4 terabytes, a copy, takes forever. We wanted to start. So I just set the read-only flag. That takes like half a minute or something, and then you can start working on those without the fear of destroying stuff. So that's not a good idea. So what we want to do is something like, let me reduce the prompt for a minute. T-Shark, or a for loop, for star.pcapng, do, no, for %a in pcapng, do T-Shark minus R %A, which means for all the PCAPs that you can find in this directory, the names will be put into the %A variable, and T-Shark will be run on it with a read command. Then DNS, lowercase, because uppercase won't work, because it's a display filter and they're lowercase. --w %A, which is again the problem that I will overwrite the file. So what I do now is, instead I will clear this and say make dir DNS. And then I go for %A in star.pcap ng do T-Shark -r %A -y DNS -w DNS \%A. Meaning I'm writing the results to the exact same file number, but in the subdirectory called DNS, so I know what I did. And if I do that, you will see that if I'm going to that directory, I just made the DNS directory already. It's empty. But as soon as I fire the command and I didn't do anything wrong, you should see the results appearing in that directory. So basically, I get files now which only carry the DNS packets. And it's running. It's running, it's running. Now it's doing the second one. So I have a result set here of 148 kilobytes. That should only be DNS packets. And now I can work on that much more easily than on the full sets of files. Basically, what you would do in the end is wait until they're all carved and then merge the results together. So I will stop that now because you got the idea, basically. So now I would go in the DNS directory and I would do merge cap, which merges capture files with -a, because I want just to concatenate them, not merge them by timestamp, which you could do, but it's slower than doing it this way. --w DNS _all .pcap ng maybe, and then tw star.pcap ng. And if I do a dir now, you'll see there's a DNS all command. This was simple because I had only a couple of files. If you do that on 7,000 files, you need to put them into directories of about 2,000 files each, then merge the 2,000 files per directory, then put the merged one into another directory and merge the merged parts together until you have the full file. Yes?
In protocols where it might be TCP continuation packets, is that kind of a DNS filter, in other words, a protocol filter, work and hold the entire session, or just the ones that are decoded to DNS, or are they a protocol that is specified?
Yeah, I think the question was, if I use a protocol filter with a name like DNS, HTTP, and something, this will only give you the protocol carrying packets, not the SYN, SYNAC, ACK, reset, FIN, whatever, but just those. So very often that is enough. Or another thing that we always do is carve the so-called essentials. And the essentials for us is every SYN packet, every SYNAC packet, every FIN packet, every reset packet. Because then we can see, are the connections established? If they don't, we don't need to look at them if we're doing forensics, because very often you see port scans where you only see SYNs and you don't have a SYNAC maybe. So we do that too. And then you can merge them with this. Huh?
Can you do it by port number?
You can do anything that is a display filter. Yeah, so basically, if you're working in Wireshark, this is like working in Wireshark in an automated mode. So any display filter that works in Wireshark will work here. And you need to have a plan how you want to do this. Right now, I needed DNS, so I filtered on DNS. I could also have done port udp.port 53 equals, would have given the same result. But there's a difference between filtering for HTTP and TCP.port equals 80, because the TCP port filter will give you the SYN, SYNAC, ACK, and everything else. And HTTP will only give you any packet that has HTTP in there, as long as Wireshark does recognize it. Okay? So one trick that I try to do, unless I'm too much in a hurry and forget to do it, is I'm not using a command like this, but instead I'm writing a batch or a command file. The reason for this is quite simple. First of all, I can easily copy it, modify it, do something else with it, and I don't have to type it all the time. And the more important reason is, as soon as I have a batch file and it's proven to work, it will work again the next time. Yeah? Very often this is something I basically stole from database administrators, because if a database administrator is doing some maintenance on a database and he's typing in a wrong command, it could end up with a broken database or a lost database and stuff like this. So most database administrators I know are only using batch files that they have tested and proven to work. And it's a good idea to do the same here, because if you do something wrong and you're doing that wrong on 7,000 files, you either lose the files or you wait for 12 hours or more with a result that you can't use. So basically, I usually build a process.cmd or something. And when you do that, you can basically use the command line that I just used here, copy that. Come on, where is it? Okay, then use an editor like Notepad or whatever you want to use. Copy the command to it. And for Windows, you need to remember, and that is something Christian already said, is that in a batch file, this needs to be %%a instead of %, because otherwise it won't work. And now I could save this to the directory and run it as many times as I need. So where's my directory? It's on this PC, in this C drive. Traces, talks, SharkFest. And I think it was gigatrace. So this would be called carve_dns.cmd, like this. And now I could, in the command line, call it here, I think. How I went into the DNS directory, so I have to go down one again. Carve DNS.cmd, and then it will just call tshark and do what I've just done and overwrite the stuff that I already had. But it's much safer to do it this way because, well, you can recycle them, just replace some characters, do some other filters, copy them to a different directory. It's much better to do it this way. All right, so useful tools. Basically, I wrote down all the tools that I'm using. First of all, of course, Wireshark. But Wireshark in this case is the last tool in the chain. So Wireshark is only used to verify things or to prepare to do long-running tasks, like is there DNS in those captures at all? I opened one in Wireshark to take a look, and as soon as I check that, I will run my tshark on it. Wireshark usually will only be used in the end when my sets are so small that I can work with Wireshark. Otherwise, before that, I won't. Because if they're too big, they won't even load. I can't do anything. So Wireshark is usually in the end. tshark is our workhorse most of the time. We do almost all our carvings with this. One of the things that we do very often is the essentials carving, like getting all the flags out. I can quickly show you this by just going into my command file here. And instead of going for DNS, what we would do is tcp.flags.syn equals 1 or tcp.flags.fin equals 1 or tcp.flags. How do I filter for reset flags? Trick question.
RST, I think it is.
Nope. It's not RST. Reset, for whatever reason. Go find a core developer and ask them. It's not called reset, or RST is called reset. So now I would call this one a TCP directory maybe. So I have to create that. I will save that file on a different name. Call it carve TCP essentials maybe. Save. And then I need to remember that I need to create a TCP directory. I can stop the other one, I think. Enough? Yes. So create a TCP directory. And by the way, that's the second advantage that you have if you're using batch files. You can prepare all the carvings that you want to do, like DNS, TCP, whatever. If you want to have them separate, just run them in a batch file one after the other. So you can just add 3 lines, doing the separate things, fire it off, come back in the morning, and hopefully you will have the results. Yeah, you could also combine them all in the result cars. So if you want DNS and the TCP flags in a file, just add them to the filter. But this way you can do it separately. So I have a TCP directory now. So I go back one and say carve TCP essentials, and now we should see there's packets appearing here now. Let's wait until it switches to the next one. And it's always a good idea before going off and leaving the office to verify at least the first file, so that you see that the carve results are what you expect. Because coming back in the morning and realizing there's nothing in the file that you needed, yeah, that would be bad. So this is how this looks like. Now you can take a look at all the SYN, SYNACs, FINs, resets. Basically, it tells you what connections were established and which one weren't. Now, that is quite a useful thing if you're tracking down connection problems or even forensic stuff where you want to know, was there an attack that was successful where a connection was made or wasn't made? And this is much more quicker than looking at the full file, because it's less, much less. It's really small. OK, so let's stop this one and continue. I think you all got the idea of this. So make a plan, prepare your batch files, have them carved through the night, come back in the morning, work with the results. Prepare the next carve files for the next night, do it again, until you have something where you think, well, I can open this in Wireshark, this is good enough. All right. So back to this one. Well, T-Shark is clear, TCP dump is clear. You can use that to do it faster if there's BPF that you can do. There's WinDump if you're using Windows, but WinDump has the disadvantage of being old and not continued anymore, so it can only be PCAP and not PCAP-NG. So if your files are PCAP-NG, you can't do this on Windows, and then you have the problem of how do I get my trace files to a Linux system to carve them there. So again, it's a file copy issue or shared access issue. Then there's one that is called Trace Wrangler. Who knows Trace Wrangler? A few of you. OK, who doesn't know Trace Wrangler? Just to see if someone's not asleep. OK, I will show it. It's a tool that I wrote and that I use, and it can do tricks nobody knows of except me. So I will try to give some of that to you now, sort of like a behind-the-scenes tour. If you have to edit files, like cut big files into smaller files, you use EditCap. If you need to remove duplicates, which I will show in my talk on Thursday, if you have duplicates from a span session, you need to remove them. You can do that with EditCap. Who has ever seen reorder cap? Nobody? Oh, maybe a few. Reorder cap, basically, if you go to the Wireshark directory, come on, where's Wireshark? Damn, there it is. Here are all the command line tools. And you probably know dumpcap, which is the capture program that Wireshark uses. EditCap, which you can use to cut files and remove bytes from files and basically split them into smaller chunks. MergeCap, we already used it to merge together files. Then there's Wireshark, which is, we don't care. ReorderCap, interesting program because it can only do one single trick. If you have frame timestamps out of order, which you can easily tell by seeing negative delta times, so you have frames in your capture that arrived too late, and you have a negative delta time, ReorderCap will put them in the correct order. This only happens if you're capturing on 2 or more network cards at the same time. Yeah? Because of interrupt issues, it happens that packets that arrived earlier are written to the file later, and if that happens, everything gets into trouble. And with reorder cap, it basically reads the whole file, sorts all the packets by timestamp, absolute timestamp, and writes them back out. Well, and the others, you know, T-Shark, text to PCAP is if you have a text dump, you can reconvert to a binary file, stuff like this. We often use text to PCAP if somebody posts a hex dump or a ASCII dump to the Q&A page, because that's so hard to read. So we use text to PCAP to convert that back to something we can use in Wireshark. All right, Trace Wrangler again can also do editing. I will show that. Merging files, Wireshark. One of the things I learned from Christian, which I didn't know, is that you can drag and drop files onto Wireshark and it will merge them automatically. That only works in the GTK version, not the QT version. So basically what you can do, if you have a directory like I just did, and I need to use a legacy Wireshark for this, I can go in here and say, well, I want to take a look at all the TCP files that I have right now, and without having to merge them first, I can just drag and drop them here, and Wireshark will merge them for me. And now I have all of them in here, and you can tell by the length of it that it seems to have worked. So that is quite a nice way of quickly merging files together, if they're not really huge, to have them without an additional step open in Wireshark. But once again, this only works in the old Wireshark version, in the GTK one. So I hope it will be transported to the new one. I mean, is any core developer here in the room? Usually I can tease them by saying this doesn't work, so I'm not going to use Qt Shark, and they're like, okay, we're working on it right away. Basically what happens during lunch at some point, somebody will stand next to me like, Jasper, can you take a look? It works now. And I'm like, okay, cool. Yeah, so that's good. All right. Other things that we can use is obviously merge cap, and Trace Wrangler again can do merging, but I don't do that much. It's not really that often that I use it for that. And then there's PCAP Touch, which nobody knows because I've written it and told nobody about it. I'm using it a lot because one of the main problems if you're working with large file sets is that, and we can see that right away here in the examples that I did, the files that we have carved from the originals have file timestamps from today. So if Christian talking to me like, have you carved the TCP stuff? I need to know what happened at capture point, time, this date, and that time. I'm like, okay, in which file is it? Because the file timestamp is not the same as it was in the original file. So I wrote a little program that helps me to fix that, and that is called PCAP Touch. Because touching, as you may know, is a coding thing where you can touch a source code to have a newer date, so it will be recompiled. So let's do this. I go into, where am I? I'm in the wrong directory, so I need to go back. Traces, talks, SharkFest 2016. Gigatrace, TCP, for example. And now I do PCAP Touch star. And if I do a dir command again, you can see now it's from the 6th of July 2014. Basically what that tool does is it opens the capture file, reads the first frame, gets the timestamp of the frame, and sets the file timestamp to that of the first frame in the file. That's basically it. Basically nothing special. But the other thing that it also can do, because somebody who used it told me it would be nice, there's a /e thing that will fix the extension. So if it realizes, oh, this is not a PCAP file, it's a PCAP-ng file, or if it's a PCAP-ng file, or it lists like a PCAP-ng file, but it's a PCAP file, it will also change the file extension so that you're not confused by this. So I use that all the time. Whenever I carve something, the last command usually is like PCAP touch star, and all the file timestamps are correct. Yeah, so this is really helpful. You can get that together with Trace Wrangler. If you download Trace Wrangler, you will also get PCAP Touch. It's in the same zip file. All right. Then others, of course, ngconvert, another program you never heard of because I wrote it. What it does is it converts trace files to PCAP NG format. And the reason for this is that I used the old sniffer box that I showed you, the huge metal thingy, and it writes the old sniffer cap format. And it has up to 8 interfaces. And this interface information is lost when you open the capture files in Wireshark because it doesn't know how to read it. I wrote a converter that will keep the interface information intact. It's quite obsolete by now because who's using sniffers? Somebody using sniffers? Like InfiniStream, something? You do? OK. This could help you to convert your cap files to PCAP-NG format and keep the interface information intact. But it may crash because I'm not a programmer. I'm just coding stuff to help me. And if it does, just let me know. OK? Just shoot me an email. Network miner, I don't know if anybody has ever used that one. That is from a Swedish guy who worked for the Swedish Armed Forces and does network forensics. It's basically a tool that you can use to carve content from PCAPs. It will extract all the IRC chats, all the emails, all the pictures, everything that can be reconstructed will be pulled out, passwords and whatnot. This is usually when I'm teaching this to, well, let's say, school kids. They're like, OK, I can scan passwords, cool. Yeah? Most of the time you can't because they're encrypted now. Network miner is quite nice if you're doing forensics because it will just pull stuff from the files for you. The problem I have with it, it's slow and it only works on single files. So, well, it's something that I use sometimes, but not all the time. Basically, I was at DEF CON a couple of years ago and I tried the forensic challenge at DEF CON. And I lost totally because I was using Wireshark and T-Shark, and everybody else was using cool tools like Network Miner, who does a lot of automation. So I was good, but way too slow. I did all the things that I could manually, but they just automated it using Network Miner, and that is really a fast way to do this. And then there's TCP Flow, which is a command line tool just doing the same as if you were doing follow TCP stream in Wireshark. So you can get an ASCII dump of things. OK, carving essentials. I basically already done that. So carving essentials means pull everything out that you need to do the initial analysis, like TCP flags, DNS, ICMP. You can carve all that into single files or put them in the same file if you want. Then merge it and take a look at it. So that is usually the first step to get your bearings and find out who's talking to whom, because then you can do conversation statistics on this stuff. Do endpoint statistics, you can count stuff. So it's helping you to find your initial ways through the huge trace files without even looking at all the content. So I've made a slide with the filter on there. So if you get the slide set later, you will have this like a reference. If you do a carve across workstations, which is really useful, like if you have 7,000 files, just do a carve job on 1,000 files per workstation if you have 7 or 8. The problem then is you need to distribute your files first and gather the results in the end, but it can be a lot faster if you can parallelize like this. OK, now a problem that I had with the job where somebody gave me a lot of packets and said, see if you can find anything. The problem with that was it was a spend port capture with a lot of VLANs, and that really messes up everything because I had the same packets after being routed twice in the capture, which means Wireshark will tell me retransmission, but in fact it's not. So I needed to separate the VLANs first. Now, you can do that, of course, very simply by using the carve thing again and doing a tshark -r and then file name and then -y and saying VLAN.id equals 3 and then writing it to VLAN3 / whatever. So basically using a display filter to carve that stuff. And that's what I did, and it was really taking a long time because I had thousands of files again. So that was something where I thought I need to make it quicker and easier. So what I did is basically, and I'm going to show this for the first time ever, I think, I'm going to run Trace Wrangler, which looked like this. It's a Windows-only tool. Nobody has seen this build, not even Christian, because there's some buttons on there now making things faster for me, which was because it annoyed me to be slow using it. So what I can do now is, if I go to my example here, the VLAN example, and I'm going to use a small subset because it's just faster. You can imagine doing this on thousands of files if you want to, but the process is quite the same. You just add the file or the files to Trace Wrangler, like drag and drop or whatever method you want. And now you can click on it and get the statistics on this. What I will do now is extract from files. So this is a task that I will define and tell Trace Wrangler what it should do. So I can filter. I can tell it to extract specific conversations for me or anything that I can build a filter for, like this, on Ethernet addresses, IP addresses, protocols, flags, and stuff like this. But right now, I don't need this. I will just go to the Output tab and, well, basically tell it to separate all the conversations by VLAN ID, like this. This is an output pattern now. So Trace Wrangler will go through all the files it has in its list, read every packet, extract, parse each packet, find the VLAN ID, find the source IP, destination IP, source port, destination port, build the file name using that values, and write to that file. If it already exists, the packet will add it to the existing file. So you get one file per conversation per VLAN. And then you can open them in Wireshark because now they're single and not duplicate anymore. So let's try this. I hope it doesn't crash because I did the final work on all of this like the day before I flew out to SharkFest. So it's quite possible that this will crash. We will see what happens. But before I do, let me show you the directory here. OK, now you can see the directory on the right. As soon as I run this, we will get an extracted directory. And you can see the PCAPs appearing while it's running. Now it's done because it was only 1,000 frames. That's really fast. But if you have more frames, it just takes longer. And now I can open each conversation with a double click and look at it. Yeah, so this is a simple way of separating them. But the problem now is I wanted to have all the conversations per VLAN in a separate directory. I could also do that, like deleting all of those again. Don't need them anymore. Change my task output scheme and just say, OK, write me a subdirectory made of the VLAN ID. Or I could even write something in there like VLAN space something. Oh, by the way, set the output file timestamp to the first frame directly without me having to PCAP touch it. OK. And run it again. So now what I should get is directories with the VLAN name. And it will sort all the conversations in there. I could have removed the VLAN ID now from the file name because I don't need it anymore, but maybe it's still good. So now I've separated them into different VLANs directories. Yeah? So now I can look at them more quickly. And the interesting thing about this is I cannot only do this with just one file, but I can do that with a lot of files. And let me show you how that works. Now, let's try something more complicated. So I run Trace Wrangler again, and now I go for the directory with the GigaTrace stuff in there, because that's what we want. So you can see here I have a ton of trace files here, like 152. If I add a file to Trace Wrangler, the first thing that it will do is scan the file for all the conversation endpoints, IPs, lots of things, which happens when I drag it here. You will see it's scanning it now. It's telling me it found 6 Ethernet addresses, IP addresses, 1,600, 700, and so on, conversations, all this. Done. Now I have one file in there. I can add more. Let's say I won't add more than that from that batch, but let me start by removing this one, and I start by adding from number 6 to number 50 or 30. It's enough. I already added them before to Trace Wrangler today, and it will store all the scan results in a database, so it doesn't have to scan them again. So if I add them now, it will go much faster because it will simply read the database. Come on. So you can see now it's reading databases instead of scanning them again, so it's adding much faster. It still can be improved, of course, because it's still a bit slow. Come on. And I think we're done. So now I have added 25 files. Total size is right now 9 million frames, 6 gigabytes in total. And I could simply extract the same stuff again, saying, OK, give me the VLAN / again. OK, and then run it. So now this will take a much longer time because, of course, it has to go through all the files. But, I mean, having this separation, and there should be an extracted directory up here, it should go much faster than doing that on your own. And by setting the values in the output file name, you can choose how you want it grouped. If you decide to do it in a different way by maybe just IP pairs, not full socket pairs, just remove the port numbers, and it will realize, OK, I've got those IP pair already, and add the packets to that and write that out again. So you can do whatever you want as long as you're using the placeholders, so to speak, and generate files based on that. So that's a really easy way to split the stuff that you want.
Can you use subnets or classes of addresses, like 192.168?
Which one?
So can you separate them out by class of IP, like 192.168, 172.16?
Not right now. This is something I would have to add, but it's real simple. Basically, I need to add that replacement line in there, and I could do that. That is a thing of maybe half an hour. So good idea, probably, yeah. All right, so this is running. Let me kill this program the hard way because we don't want to wait this long. It's just to show you that it can do that on any number of files. The biggest number of files I ran this on were 1,000 files of 500 megabytes. So it's like 500 gigabytes? No. Yeah, 500 gigabytes. It took like forever and a day, but it was still faster than looking through it manually. So it can handle that, but you need a lot of memory. I mean, my PC at home has 32 gigabytes, and it used, I think, 24 of them. So yeah, it uses a lot of space for the metadata. Good. So this is how you can separate the VLAN stuff. You can also use the T-Shark carving jobs if you want to. Trace Wrangler has the advantage of directly pulling it apart into separate conversations, IP pairs, whatever you want. So you decide what you want to use. Yeah? If you're on Windows, you can use it. How much time left, Hansen?
You have
30 minutes?
I think so.
OK. All right, so hints for VLAN carving. This, once again, is for the record or for your reference. What we can do, for example, to improve performance is not to carve every VLAN into a single file, but carve multiples into files and then do another carve job on the smaller files and separate them again. It's a divide and conquer process. So if you have 50 VLANs that you need separated, do a batch job that does 25 of them in one file set, 25 in the other, then do it again on the 25 into, I don't know, 12 and 13, and then it gets faster each run you do because you're only working on half of the packets for each subsequent run. This is something Christian already mentioned. Or use TCP dump and WinDump, which is sometimes 100 times faster because it just does BPF matching on offsets. One thing, basically, by the way, that killed me in the task where I had this find anything you can find task was that T-Shark was running into trouble because one of the dissectors crashed, basically, and delaying the whole carving process a lot. And what I did is I created a new Wireshark file where I only enabled the protocols that I needed. I don't know if you've ever done that before. What you can do is tell Wireshark, well, I don't need everything decoded. It's enough for me if you can analyze some of the protocols. Here is a protocol list. I think it's quite long, as you can see. These are all the dissectors that are running in Wireshark. Whenever you open a trace file and it finds something where it thinks, well, I need to dissect this. What I did is I disabled all of them and then went through the list and said, well, I need Ethernet, I need IP, where is it? IPv4, IPv6. It's probably a good idea to have IPv6 fragmentation, hop by hop, and routing headers, which are extension header things. Then what else do I need? I need UDP, probably. ICMP is a good idea. ICMP6 is a good idea, and TCP is a good idea. So that would be a minimum set that I would use. And now, whenever I use that profile, I have to specify it with -C, I think uppercase C. It would only run those dissectors and leave all of them out that are not enabled. So it's faster and it crashes less often. Yeah, so that can improve your carving process too. And that's what I did. And it improved my carving process by the factor of 20, I think, just by doing that. Because of one dissector was running into trouble all the time. I think I can reproduce that if I just go into the 5-tuple VLAN thing and do a quick T-Shark -R. Let's go for tcp.flex equals syn for the fun, .syn equals 1 for the fun of it, minus w something dot pcapng. And if I do that, you will see the dissector is failing here. And I had to deal with it like millions of times. And it really slows down the carving process. So that was when I disabled all dissectors except IP, TCP, and TCP UDP. Okay? So important here, if you're writing a carve job, all the protocols that you are carving on need to be enabled, which is something I forgot in the last 4 terabyte trace, and Christian is smiling at me right now because at some point he was asking me like, where are the ICMP traces? I mean, where is the carve result for ICMP? And I'm like, I'm sure I put them in my batch file. I opened the batch file and it was in there. And I was like, damn, I forgot to enable them in the protocols. Because if the protocol is not enabled in the Wireshark profile, it will not recognize it and not carve it. So I was like, okay, 12 hours carving for ICMP again. Yeah, so double check, please, because it's a long time if you're working on batches this big. So even me doing this for a long time now can fall into traps like that. Cancel. Okay. By the way, if you do this in Wireshark and disable all the protocols, it will get you a really funny result because it will not show much more. Disable all. Okay. Ugh. Yeah, so this is the result. Okay, let's go back to enable all. Okay. Good. Now, extracting frames, I already basically showed that. You can do that with Trace Wrangler or with a T-Shark job. Extracting basically means pulling stuff automatically. So hints for extraction is if you're doing this with Trace Wrangler and add filters a lot, they will slow down Trace Wrangler. I will be using that feature on Thursday. And it worked well with small filter sets, but with big filter sets, I think one of the things we did was filtering on 50,000 filters, and that was really not working well. So that was one of the reasons why I rewrote the code for that. So I still need to improve it. And the output settings will define what file name and what file in content you will get. And now for something really interesting, because working with large file sets may be something that is really a problem if somebody tells you, find out something that is going wrong. So I will be using one of my large file sets again, like the gigatrace, but I only use like 5 or 6 of them. You could add hundreds if you want to. So if you do that, drag and drop it here, it will read the database again, saving me from having to scan. And now I have a tool in TraceWrangler that is called the conversation details statistics. If I open that one, this looks pretty much like what you have in Wireshark, a conversation statistics, but it's over all the files you added in TraceWrangler. So if you add like 100 files, the statistics will show you the combined statistics over all files. And if it sees a conversation that is spanning like 5 of them, there will be only one line giving you the details for the full conversation. And if there's something that is interesting for you, you can double-click it, and it will be pulled out and opened in Wireshark right away, which I do all the time now, because it saves me from having to refilter all the time. And I added a couple of columns that are not in Wireshark that I use quite often now. For example, the initial round-trip time. So if you want to know which conversation is really slow when starting, just sort by it. You have an initial round-trip time of 18 seconds here. Interesting, what is this? Double-click it, and in the status bar down low, you will see an extraction status counting up the percentage, and here it is. It just opened a temporary file. I can look at it. It doesn't look too good. So let's find out what the initial round-trip time is. It starts with a SYN, SYN-ACK, another SYN, SYN-ACK, 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 SYN-ACK. Here's the ACK. So from the last SYN to the ACK, 18 seconds. So TraceWrangler was right. It was really 18 seconds to open this connection. So that's not good. But I have to admit, this is a capture I've taken at my own computing center, and there is a web application running that people access over the air from mobile phones, and if the carrier network is really not in a good position back then, or at the location of this guy, the round-trip time is bad. So it's always the client doing this, so you can really go through it. The other thing that I added is, for example, the packet ratio. It will tell you who's sending packets more, the one guy or the other. And you can use that to find some that are not sending. If I go to the top, position 1, I should have some that, the zoom factor is killing me. Here you have some where you have a 0 to 100 ratio, one-sided communication, or not established communication. It will also show you all the flags in this column, and it will give you a status like, I've seen no handshake or teardown. I have not seen a third ACK, just seen SYN and SYN-ACK. And there's something like SYN rejected. Okay, SYN rejected, what is this? Double-click it, it gets extracted, it gets opened, and you see SYN, SYN, SYN. Yeah, it's not rejected because the SYN sender sends the reset. That is a problem that I still have, that this logic of analyzing the TCP handshake is not working 100% correct. I have a complete rewrite of that already, but I didn't dare putting it in yet. But very often you can see that somebody's trying to get a connection and it doesn't work by just looking at this conversation table. And basically this table is what saved my bacon when I got the task of, here's that many, find something. And I used the status column here all the time, like find something that is interesting. So you can sort by it, of course. And maybe I will find a SYN rejected at some point that is much more interesting, but I have also something like TCP half open, then reset. Let's see if that works. There it is. SYN, SYN, reset. What's that about? Yeah. So with this, it's really easy to find conversation that seem to be in trouble. And double-clicking, basically, TraceWrangler will do this. Because it scanned all the files when I added them the first time, it knows exactly at which packet the conversation is first seen and at which packet it is last seen. So it will start reading the file and not the first file. It will start reading the file where the first packet of what I want to extract is in, read until it finds it, then starts reading until it knows that it's finished because it knows where the last packet is, stops, extracts it to a file, opens Wireshark, and you can look at it. This is why it's so fast. And it will get even faster as soon as I start remembering the offset where I have to read. I can show all of this to you later, Hansang. And this way I can really add tons of files and just open them double-clicking and analyzing each conversation that I find interesting. Be it because it's big, because it's having a large initial round-trip time, all that things I can do real quick. The other thing I can do is if I have something specific, there's a filter thing down here. So if I want to find everything where there's a reset somehow, I can just type in reset, and it will remove all the conversations that don't have the word reset anywhere in the IP address. Okay, of course, there's no word reset in the IP address, but it will show me all the ones where I have a reset named in the status. So this filter is not the same as the Wireshark filters. It will match against IP addresses, ports, and the status. So you can do stuff like, okay, I want to see everything from, let's say, 93.211. whatever, and then everything is removed that doesn't have this string in the IP address or the status bar or the status column, and now can look through all of what this IP addresses are doing. So if you know that there's trouble with a specific thing, this can help you narrow it down. And the largest thing I did with this conversation statistic was the 1,000 files of 500 megabytes each, and then opening this statistic, which takes a long time because it's a lot of data. I think the database was over 4 gigabytes in size, but you can work on that if you want to and filter on it. The other thing that you can do is go for the IPv4 conversations, and in here it will give you an additional column that is called average round-trip time. So if you have a station that is constantly having bad initial round-trip times, you can find it here. So this will do an average over all TCP connections seen between those two IPs. So those two IPs here, 93.211 and so on to this IP, is having 31 TCP flows. That is this number here. So I know there's 31 connections. And the average round-trip time is 142 milliseconds, which is pretty bad. So now there's something I can't guarantee that it will work. I can double-click here, but I'm not sure if it will crash because that is something I didn't try that often. Let's see. I usually work always in the TCP tab, but that works also. So now you get all the conversation in here, and if that was done correctly, the statistics in Wireshark should tell me that there's now 31 communications here. Yeah, so it pulled all the conversations from the IP pair tab with a double click. And that way you can just really get quickly into stuff because you don't have to worry about the multiple files and where it starts, where it stops. It will just pull it out for you. Yeah? So unless you have a conversation that is really stretching across all the files that you have, and sometimes I have that, it has to get all the packets from all the small files too. That will take a long time to extract, but very often you have short conversations that is just in 1 or 2 files, and with a double click you just wait a few seconds and Wireshark will open it and will show it to you. Yeah? So this is the fastest way I'm working with large file sets now, because throw it in there, let it compute all the metadata overnight, and in the morning I can open the dialog and just start working. And if it crashes, I just add the files again. It is much faster because it reopens the details from the database, which I can show you. It's in that directory. And it's called traceintel.database. It's an SQLite database. So if you want to take a look at what's stored in there, you can. I usually do that with a plugin for Firefox, which is called SQLite Manager, I think. This one. And this is how a database looks like. You can see here are all the IPv4 conversations, endpoints, TCP conversations. It's all stored in here, so it doesn't have to do that all over again. It just reads the database. Yeah? And the trick is that there's a file list with the name, and the name will, as soon as you add a file that is in the database already, it will just pull the details from the database. And it will check if you have modified the PCAP file, because if the PCAP file has been modified, it needs to be rescanned, of course. It will do that and rescan it if necessary. Yeah? So basically, that's what I'm using a lot to work on big files. And since TraceWrangler is free to download, you can get it at www.tracewrangler.com. The last stable version I did was last SharkFest, I think. That is this one. It's so old I cannot recommend it, but I didn't dare to put out a new stable because I was pulling apart so much under the hood. Usually I recommend going to the semi-automated build section where I put builds that are, from my point of view, good enough to be distributed. And you can see the last one is from 18th of May. The one I'm using today is so new that I'm not even having uploaded it to the site, but I will at least right after SharkFest. So if you want the really new one, which works much better than this one when it comes to extraction, because all the extraction tricks I did just now was built in last week, you have to wait for that one. Or just come up with a USB stick to me after the session and I can copy it to you. Yeah? So that's what I'm using now, and get it if you want. And you can be as fast as I am right now. Okay, how much time do I have left? I don't think I have much left. Huh? 70 minutes. Okay. Anybody wants me to go through Megalodon challenge? Because it's the last demo I prepared in case I have enough time, or do you want to do a Q&A? Who wants to do a Q&A instead? Okay, who wants me to do this one? Okay, enough. The rest is still asleep already, or already asleep. Okay, who's tried the challenge? I think I asked that, and it's a couple of people, okay. That was a challenge I did last year, and I already said many people got confused by it because there's so much stuff in there. I put the solution to this on my blog, so if you get lost in my next couple of minutes, you can always open my blog and read it and get the solution there. It's quite interesting because this was a thing where the customer called on a typical day and time where it tells me by just the phone ringing something must be up. Because if your phone rings on a Sunday at 4 p.m. and you see a name from a customer where you know that they only call you if there's either a incident or a forensic incident or a network problem, you know right away, there must be trouble. So he was calling me and saying, well, they got this web application set up. It's brand new. They're testing it. They're doing a stress test. And in the stress test, it turned out that when the web application server was talking to the content server who had to deliver content to the web application, some connections would fail. And that would increase over time. So the longer the test ran, the more connection would not work. So I was like, yeah, okay, that should be simple. Let's do a capture. If you think about a capture setup, it should be quite obvious that in a case like this, if you need to tell if the network is a problem or not, you cannot go by a span port. Because why can you not go with a span port here? Does anybody know?
That device could have an issue.
That device could have an issue, and the problem could be if you're talking about packet loss, like let's say the web application server wants something from the content server and sending a SYN packet. You see the SYN packet here, but not over there. What does that mean? It could be lost in the network. It could also be lost on the span port. So it was on the network, but you didn't get it because the span port dropped it for some reason. So if you want to find out if a connection is working and you see all the packets from one side also on the other side, that's the only thing that you can do is use a full duplex tab. Because that's the only way where you can stand in front of anybody challenging you and say, well, I used a full duplex tab with a capture device that was recording everything that was there. So if it isn't there, it wasn't there. Yeah, and that's the only thing that you can do. So I inserted 2 tabs. I had a capture device that was recording both at the same time. So I even had the timestamps from a single device, so I could tell what was happening. There was supposedly a load balancer in the middle, which I'm not too sure that there really was, because the capture results were slightly strange. And then basically my task was to find out if connections fail and why. So what is the first step that I have to do after doing the capture? Find the connection setups between those 2 IP addresses and find out if there's something where I can tell that the connection doesn't work because of the network losing the packets, or if the connection doesn't work even though it makes it all the way through the network. These 2 options are there. So that's what I had to do. And focus, focus, focus. The customer is only interested in those 2 IP addresses. So in the traces that I distributed, there were a lot of other IP addresses. And many people taking the challenge were like, this is interesting. And they were asking me tons of questions about this. And I was like, I don't know. I never looked at it. I have no clue what you're asking me because I didn't need to look at it. Yeah, so that's what I did. And in fact, you can solve this a number of ways. The quickest being probably, and you can guess that, by using Trace Wrangler. So where is it? There's those other 2 files are distributed. And let's say I have the content server trace open. Loading, loading, loading. This will take a while. So I hopefully can stop it at some point. But I think I have to load it. But I still got 12 minutes as far as I can tell, so let's try this. Okay, I stopped opening the file. And now what I would do is go for the conversation statistics, because it's always good to look at statistics first if you don't know what's happening, because it will get you some sort of a reading already, so you can tell, okay, how many conversations do I have, how many bytes are transferred, is there anything that is kind of funny? So this is a TCP conversations here, and you can tell right away that Wireshark is crashed. In here, you see 172.28 something. And I don't know if it was visible on the slide, but if you look at those 2, 192.168 and 10.0. So there's no 172 something. So many people looked at the 172 something and said, well, this is strange. And I'm like, I looked only at those 2. So what I could do is open the trace again. But this time, I do a little trick here. I start Wireshark empty. I say, open, please. Now I need to navigate to my trace file again. SharkFest 16. Galodon content server. And now I can go in here and say, well, read filter IP.address equals 192.168. 1.1 and IP.address equals 10.0.0.10. I hope those were the 2.
Yeah, that's a D.
Right. The screen is so small I need to zoom in. Still some, there's a comma there. There's another comma there. Why doesn't it get green? Probably. Yeah, that looks funny. Thank you. Okay, now let me quickly check if those were the 2, because otherwise it is futile. 192.1.1 and 10.0010. Okay, so if you never used a read filter before, this basically is a display filter, and it will only accept packets that match the filter when reading the file. So I skip everything already when loading the file that is not matching those filters. So I discard everything that is not any of those two IP addresses. So let's open this. Hope that it doesn't crash again. Okay, should be enough. I stop it. And you can see those are the only two IP addresses that I have. Yeah, that's really a nice way of reducing packets on load. Conversation statistics, there they are. Please don't crash. Otherwise, I have to hunt down core developers. And again, you have conversation statistics here, and what I did is go for low packet counts, because all the conversation between those two should be exchanging information, which means I need to have a connection established. How many packets do I need for that? 3. It probably should have a teardown, so another 4 maybe if they do FINAC, or if they are not really nice to each other, they will do reset. So I should have a minimum of 4 packets. But if there's content in there, and it should be, it needs to be more than 4. Now I have a couple of 3s, which is kind of interesting because this could be something fishy. So let's just say, okay, the first one with only 3, apply a filter, select it, A to B and back. So this is the fastest way of singling out a conversation without even knowing which one is interesting, by going into the conversation statistics and then finding something that is kind of strange and filtering on it. A to B. Please don't crash. And then we should have something interesting, because 3 packets is not that much. Come on. Yeah, so what do we get? Cincinnati ACK push. So problem here right now is I stopped the loading, so maybe it continues later. Yeah, so I would have to load the whole file. But this would be basically the way of finding conversations that are not really working. Yeah? What I could do now is to find something where maybe, if I suspect that the one side is trying to get a connection established but the other doesn't answer, I could just do something. First, I go in the filter bar and say tcp.flex equals 2. Does anybody know what that does? This is just SYN, yeah, because the number 2 means that only the flag or the bit for the SYN flag is set. That is the fastest way on filtering just the SYN packet. Because many people do this, tcpflex.syn equals 1 and tcp.flex.ack equals 0. So I only want the SYN but not the SYN ACK. I'm so lazy I don't do this. What I do is flex equals 2. That means flag cannot be set for ACK, so I get all the SYN packets. Go, go, go. You can imagine what you're doing with 4 terabytes, right? It's like, oh. Come on, get it done. So now I get all the SYN packets. And what I do now is, again, use my conversation statistics, but with a little trick. I say limit to display filter, which will only build the statistics on what is visible in the Wireshark in the background. So I get a statistics now for all the SYN packets. And this is basically what we do. We try different approaches to see, can we find something that is strange? The first one didn't work because it could have been a normal conversation, but I was too lazy to load the whole file. If you load the whole file, that trick actually gets you the strange connections where it doesn't work. So here's like 1, 1, 1, 1, 1. I don't care about 1 because that means it doesn't retry. If it doesn't retry the SYN, It must have worked, probably. Come on, there must be more than that. Scroll down. Here's one with 3. So let's filter on this one. This will destroy the SYN filter in the background, which is sometimes annoying, but can't be helped. So let's see what that one does. 3 minutes left. Okay. Okay, so this is interesting here. Can you see? What's that? That basically means hello, nothing. Hello, nothing. Hello? Oh, hello. So we're starting to talk after the 3rd try. This shouldn't happen. Not in a local area network with only a few components between the two. Of course, one thing I also did is find that exact communication on the other trace so that I could compare the two. And they were absolutely identical, except for the timings, of course. And that way I knew, and I did a couple of examples just to be sure, not only going for one, that everything I saw on one side, I also saw on the other. So I could rule out packet loss in the network, at least for this kind of problems. There is some packet loss, but nothing that is important. And that immediately meant I only had to look at one side of the traces, and I could ignore the other trace because I knew one side is good enough. So I cut my amount of packets in half by knowing that I only needed to look at one side because the problem was seen on both sides. So this is a conversation that has trouble starting, and the question now is, why does it have trouble starting? And this is the next point where almost all participants of the challenge ran into trouble. Because we also will see, if you're filtering on more stuff like this, that there are SYN packets that are never answered. SYN, 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 nothing. And the big question is, how can that be? Because what are reactions to a SYN packet? You get either a SYN ACK back or a reset. But when do you ever get nothing back? When there's a firewall, usually, or an ACL or something, but there was no firewall. Because, like you said, no firewall will just allow a couple of them, but not all. At least if you're not doing some fancy stuff like rate shaping and stuff like this, and counting connections per port and socket and stuff. So there's no firewall because we know that stuff is getting through, but we see sometimes that a SYN doesn't get answered and we don't get a reset back instead. So what can that be? And that was really the biggest problem for everybody. And nobody got it. Nobody. Yeah? No. You can. What?
The SYN backlog?
No. There was no SYN backlog. Nothing like that. There was no SYN flood protection. All the features that people told me, nope, wasn't. No load balancer. You can continue like forever, and you will probably not find it.
Was it a DOS attack from that
Nope.
172 address?
No. There was no DOS attack, and there was no SYN flood protection. So the trick here is something that only a few people know about. So this is really secret, and you can take it back home with you. I only stumbled across this by poor luck a couple of years ago, and this basically saved me here. There is a firewall. It's the Windows firewall on the server. The Windows firewall on the server has a very strange behavior. If the port is open, so there's a firewall allowing connections to port 5433, and if there's an application listening to that port, so the socket is actively being opened by an application, there will be answer packets. If the port is closed, the firewall will behave like there's no allow rule. So it will drop incoming packets. So the Windows firewall takes the advantage of knowing if an application is listening on the port, and if there's no application listening on that port, it will not answer any packet coming in. So it's like an adaptive blocking thing. And that means we don't get resets back because the firewall, as soon as the application crashes, the socket is released, and the firewall will just ignore the incoming SYN packets. So what's the next step? The next step is turn off the firewall, do the trace again. And I was expecting people to tell me, like, it would be great if we could do another trace and with the firewall off. And I was having a trace ready for them. Nobody asked for it. Nobody. Yeah? You did, but I told you what the problem was. So that doesn't really count. And others asked too, because as soon as I told them what the problem really was, they all said, well, it would be great to have a firewall trace. Yeah, here it is. It's also mentioned in the blog post, so if you want to download that one, I can show you. And basically, you need to have that one because, and that is here, if you look at that, you will see that whenever a SYN is not answered, you get a reset back. So it means that the application holding the socket was not available at the time, which basically means the application crashed and released the socket. So it's a server problem that was basically hidden behind the firewall, protecting it from being identified quickly. And that was really a bad thing. The only thing that saved me really is that I knew how the Windows firewall behaved, and I had Christian, because I was driving back from the customer side and we were talking about it, and I said, well, I got the SYN thing, but there's nothing coming back. And he was like, firewall? And he meant a normal one, probably. And I was like, right, firewall, the Windows firewall. Right, we need to turn it off. And then we did the capture with it turn it off, and then we're seeing the reset packets, and it was clear. This doesn't work because of the application not being able to service the port. In my report for the customer, I used Pilot, or I think Cascade Analyzer, something it's called, to draw a graph of all the TCP packets, SYN, reset, and SYNAC, I think. And you can see that at some point, the resets start coming up, and that basically, there's an overload on the application, and it's refusing to service and restarting all the time, doing some connections again, then crashing again, and that's what happened. Yeah, so if you want to read the details, go on my blog. It's all in there. You can get the trace files too. Spend your time on it. You can use Trace Wrangler to have it show you the connections where you have a SYN reset coming back, because it does that in the status column. That was one of the things that helps to do it really quick. And other than that, I think I'm 4 minutes over my time. So thank you, and please do not forget to do the session feedback thingy on the phone thingy. Okay? Thank you very much for staying with me for that long time. And